Hello. We will start some topics that are covered in your quiz number 8. Hopefully these explanations will help you when you are problem solving on that quiz number 8. We'll start first with order of operations, PEMDAS, known also as Please Excuse My Dear Aunt Sally. PEMDAS is P for parentheses, E for exponents, M and D for multiplication and division, and A and S for addition and subtraction. Notice multiplication and division is left to right and addition and subtraction left to right. This is the order that you do the operations when you're given an equation or an expression that you are to evaluate. First example, what is the value of 4 times 4 minus 3 times 3 minus 16 divided by 4? Now, you see, we will do them in order, multiplication, left to right. Now, what's the first multiplication? 4 times 4. So we do 4 times 4, and we get 16 right here. What is the next thing that we do? We see another multiplication, 3 times 3, and that's 9. Now, the next operation will be division, and that's 16 divided by 4. And 16 divided by 4 is 4. So what we're left with is 16 minus 9 minus 4. 16 minus 9 is 7. 7 minus 4 is 3, so our answer is 3. Now, let's take another order of operation problem. We want to simplify this expression. 14x plus 5, and that's a bracket, 6 minus, and 2x plus 3 is in parentheses. So what do we do first? Parentheses. And there's where our parentheses, 2x plus 3. So the minus goes outside of the parentheses. Notice where the minus is here. A minus 2x outside the parentheses make this plus 2x a minus 2x, and the plus 3 a minus 3. So we have a minus 2x minus 3. So now let's plug that into the bracket. 14x plus 5, we have our 6 here, minus 2x minus 3. Now next we'll do the expression in the brackets. 6 minus 3 is 3. So what we're left in the bracket is what? 3 minus 2x. Now multiplication will come next. So we multiply the 5 times the expression 3 minus 2x. 5 times 3 is 15. 5 times minus 2x is a minus 10x. Now we combine our variables. 14x minus 10x will give us 4x. And we have our constant 15. So our answer is 4x plus 15. Okay, now let's take a word problem using PEMDAS. We have a carpenter laying a floor, $10 per square foot. The floor is a square-shaped hallway. And if it's square-shaped, that means all sides are equal. And you have a $25 off coupon. Now, the first thing we'll do is find the area. And area of a square is side square. So the side length is 6 feet. So 6 square is 6 times 6, which would be 36 square feet. Now, the cost is going to be the area times the cost per square foot, which we were given as $10. So 36 square feet times $10, for 1 square foot will give you $360. And since we have a coupon, we can subtract out that $25 savings, and we've got $335 as the final cost of the floor. Okay, next topic we'll look at, and that was in your quiz 8, is rounding numbers. Now, why do we round? Sometimes we don't need an exact amount, okay? We just need an estimate. Now, take example here. You're paying for a meal. Your lemonade costs you $2.50. Your sandwich costs $5.95. And your cup of soup costs you $1.85. So if you want to get an approximate total, you could round the $2.15 off the $2, $5.95 round off the $6, and the $1.85 round off the $2. So when we add the 2 plus the 6 plus the 2, we get an approximate amount of $10. And as we say, it makes our calculation simpler. Now, let's look at some rules for rounding. First, you're going to decide which is the last digit to keep. And that's where place value comes in to play. So make sure you review your place value with whole numbers and with decimals. Okay, so once you just decide what the last digit you want to keep, if the next digit to that digit is less than 5, this is called rounding down. If it's 5 or greater, we call it rounding up. Okay, let's take an example. Suppose we want to round 74 to the nearest 10. Now, the 10th position is where you see the 7. 7 tens make 70, right? But look at the 4. The 4 is less than 5. So, no change then to the 7, and we just put 0 to round it down. But suppose we had 86. We don't want to round it to the nearest 10. And the 10 is the 8th position. 8 times 10 is 80. So we want to keep the 8, but the 6 is 5 or greater. So we will increase this by 1 to 8, and now we round it up to 90. Now, when you round in decimals, you determine which number you be left when you finish. And if it's tenths, you need 1 number after the decimal point. If it's hundredths, you need 2 numbers. If it was thousandths, you need 3 numbers, and that's the way you round. Now, here's an example. This number, 3.1416. The 1 here is in the 10th position. The 4 is in the 100th position. That's where we want to round. So we look at the 1 that's right here after the 4. That number is less than 5, right? So if we want to round to the 100th, we just will write this as 3.14 because the 1 is not 5 or greater. If it were 5 or greater, we could bump this 4 up to 5. Okay, so that's rounding down. Now, in some situations, you're asked to take the fraction of something and round it to the next. And it may not be 5 or greater, okay? But you just follow the instructions. So in that case, if you were rounding to the next highest value in the 1's position, 2.4 would round to 3. And if you were rounding to 2.6, that would also be round to 3, where any fraction is rounded to the next number. So those are specific instructions that you have to look for. And I think you had something like that in a problem in your quiz number 8. Okay, let's look at functions rate of change. Now, we said earlier in a post that the rate of change is a slope, which it is, which means the change of y over the change of x will give you the slope, and that's the rate of change. Now, I gave you a table with x and y values. We said functions can be represented by y or variable of x or of whatever literal it is, but it can be represented both ways. Like here, f of x represents a function, g of x, p of x, etc. Here we're just looking at a table. Now, if we want to find the rate of change, we take the difference of y divided by the difference in x. So that's first one, 32 minus 22 divided by 4 minus 2. That's what you see here. That gives you 10 over 2, that's 5. Here we had 42 minus 32 divided by 6 minus 4. That's also 10 over 2, and that's 5. 52 minus 42 divided by 8 minus 6, 10 over 2, which is equal to 5. Now note the rate of change is a constant. Now this will be true for linear functions, but nonlinear functions such as quadratic and exponential are nonlinear. So if you were given functions and you determine which ones are linear, the rate of change being constant for the values of x and y, that would determine whether you have a linear function. Of course, if you had a graph and if it's a straight line, it's a linear function because nonlinear functions do not have straight lines. Okay, now next topic deals with geometry. Now, let me remind you that you have a TASC math reference sheet for your formulas. If you don't have one, let me know and I will send you one. All right, we will calculate here the volume of a sphere, volume of a cone, area of a trapezoid. Now, the first problem tells you about soccer balls. Now, soccer balls are round like a sphere, okay? We're looking here for the volume of the soccer ball. So in order to find the volume, we would have to know what? Radius and pi. Now, let's look at the formula. Now, notice in this problem, we're given diameter, and you'll see that you have to use that diameter to find the radius. Now, the formula for a sphere, 4/3 times pi r cubed. That's r raised to the third power. Now, to find the volume, we need the radius, as I said before, but the diameter is given as 24. So the radius is half the diameter. So we just take our diameter, divide by 2, and we get our radius equal 12. And that's 12 centimeters. Now we can just plug that into the formula. 4/3 times pi, 3.14, times the radius 12 raised to the third power, or radius cubed. 12 to the third power, this would be a calculator type problem on your TASC test. And you plug in the 12 and the power, and you should get 1,728. Now, 3.14 times 1,728 gives you 5,126. We multiply that by 4, we get 21,703.7, and we divide that by 3, we get 7,234.6. And I think the problem had said that it should be in, find the, I think it said the 10th. Well, it's rounded to the 10th. Sometimes it specifically tell you what to round to. Right here, round your answer to the nearest 10th. So we expressed it as 7,234.6. That's to the nearest 10th. Now, the next thing we see is a silo, and a silo is shaped like a cone. So this is a two-part problem. We have the silo shaped like a cone, and we will have to find how long it takes this silo to empty at a rate of 25 cubic feet per minute. So And it says round your answer to the nearest minute. There we are, rounding again. Okay, so the formula for cone, right here, 1/3 times pi r squared h, right here. Is the formula. 1/3 times pi r squared h. So pi is 3.14, the radius is 10, and the height is 15. So substituting those in the formula, we have 1/3 times 3.14 times the radius 10 squared times the height 15. Okay, 10 squared is 100. So we have 3.14 times 100 times 15. That gives you 1,570. Okay. Well, that's 1,570 because notice here we're dividing this multiplied result by 3. And the volume is 1,570 cubic feet. But now the second part of the problem says, if you're releasing wheat from this silo at the rate of 25 cubic feet per minute, how long would it take for the silo to empty 1,570 cubic feet? That's a division. So you take the 1,570 cubic feet divided by the rate, 25 cubic feet per minute, and you get 62.8 minutes. And it asks you to round to the nearest minute. So notice the 0.8 is 5 or greater, so we bump the 2 up to 63. So it would take about 63 minutes for the silo to empty fully. The next problem deals with a trapezoid. We have a wooded area shaped like a trapezoid. And this trapezoid, notice we have a walkway we put between the sides of the trapezoid. It's almost in the middle, okay? Now we want to calculate the area after the addition of the walkway, which means we need to find the area of the trapezoid, and we need to find the area of the walkway and subtract that area of the walkway from the trapezoid, and we will get the area of the trapezoid after we've added the walkway. Now, the area for the trapezoid is 1/2 times the sum of the two bases times the height. Now, here are your bases, 92 meters, and the one here at the bottom, 128 meters, and your height is 40 meters, okay? Now, that 4 meters there is the width of your walkway, and we'll need that to find the area. So let's first calculate the area of the trapezoid. 1/2 times the sum of the bases, 92 plus 128, and times 40. So 40 times 92 plus 128 is 220. 220 times 40 is 8,880. And if we take half of that, we get 4,400 square meters. Now, the length of the walkway is length times the width, 40 times 4, which is 160 square meters. Now, if we subtract that from the area before we added it, that would be 4,400 before we added the walkway, minus 160. So after adding the walkway, the area of the trapezoid, the wooded area shaped like a trapezoid, would be 4,240 square meters. In other words, it decreased by 160 square meters, which is the area of the walkway. Okay, let's go to our next topic, substitution of a variable. Now, substitution of a variable means that you're given some values of the variable and you substitute them in the expression or formula for that variable. Now, our question here is, we have an equation, We're given a value of z, and we want to calculate the value of x. So 4z plus 6 is x plus z. That means wherever we have a z, we want to put a 2. So 4z becomes 4 times 2. X plus z becomes x plus 2, because for z, we put the 2. Now, 4 times 2 is 8. 8 plus 6 is 14. So we have 14 equal x plus 2. So if we subtract 14 from both sides, we get 14 minus 2 is 12 on the left, and we get x, because plus 2 and minus 2 is 0. So we get x on the right. So 12 equal x, or expressed another way, x is equal to 12. Okay, let's take another substitution. If y is minus 5, what is 3y squared plus 7y minus 4? Wherever we see a y, we want to put a minus 5. So 3y squared becomes 3 times minus 5 squared. 7y becomes 7 times minus 5. Now, minus 5 times minus 5 is a plus 25. Remember, like signs multiplied give you plus. And 7 times a minus 5 gives you a minus 35, because unlike signs multiplied give you negative. So we have 75 minus 35 minus 4. Subtracting 35 from 75, we get 40. And 40 minus 4 is 36. Okay, let's go to our next topic, probability using a deck of cards. In a pack or deck of 52 playing cards, we have 4 suits. Each suit has 13. 4 times 13 is 52. And we have spades, hearts, diamonds, and clubs. Clubs and spades are black cards. Diamonds and hearts are red cards. In each suit, we have an ace, king, queen, jack, and then we have the numbers 10 through 2. Now, king, queen, and jack are called face cards. So with 4 suits, 3 face cards per suit, 4 times 3 is 12. So there are 12 face cards in the deck of 52 cards. So that's basically all you need to know to answer any problem involving a deck, any probability problem involving a deck of cards. Now, just to review, probability, number of favorable outcomes over total number of possible outcomes. Now, each probability here, we are taking a card from a well-shuffled pack of 52 cards. Now, find the probability of a 2 of spades. Now, in a deck of 52 cards, there's only 1 2 of spades. There are 13 spades, and there's only 1 2 in that suit. So the probability, 1 number of favorable outcomes divided by 52, total number of cards in the deck, will give us probability of 1 over 52. What's the probability of getting a king of a red color? Now, you have each suit has a king, and you have 2 red cards, right? You have the hearts and the diamonds. So that means you have 2 kings that are red in color. That's the favorable outcomes. The total of all the cards is 52. So 2 over 52 is the same as 1 over 26. Just divide the 2 by 2 and the 52 by 2, and you get 1 over 26. Now, what's the probability that it's neither a spade nor a jack? Now, there are 13 spades in a deck of cards. Remember, each suit has 13. That means the non-spades would be the total 52 minus 13, which is 39. The number of jacks out of 52 cards is 4. But we will only look at the jacks in the 3 suits, because the jack in the spades is counted among the spades, all right? So we take the number of jacks as 3. So neither spade nor jack would be 39 minus 3 is 36. Probability of getting neither spade nor a jack. So the number of favorable outcomes will be 36 over the total again, which is 52, number of cards in the deck. And that's 36 over 52. Now, if you divide 36 by 4, you get 9. 52 by 4, you get 13. You always try to simplify your probability, all right? Now, let's look at budgeting using dollars and another currency. Now, Emma is saving her money to go on a big summer trip. She's going to 2 countries, US and Russia. She has a total of 2,500. GPB is Great Britain pounds, so she has pounds, all right? The exchange rates are 1 pound is $1.28, it's US dollars, and $1 in US is 29.35 rubles. Rubles is the currency of Russia. Now, she knows she can only spend, the maximum amount she can spend in Russia is 32,285 rubles. Okay. Now, how much should she spend while she's in the United States out of her money that she saved if she wants to spend as much cash as possible in Russia? And this was given as a multiple choice. Now, one of the best methods for Emma to solve her problem is to convert her US dollar value to rubles, all right? And we have a conversion here, 29.35 rubles is 1 US dollar. So if she has 32,285 rubles, the maximum she can spend, we can convert that to dollars by dividing the number of rubles that she can spend in Russia by the conversion factor of rubles per 1 US dollar. That would give us 1,100 US dollars. So that means she must keep 1,100 US dollars to take in Russia for her trip. Now we need to convert her pounds to dollars. That's 2,500 pounds we want to convert to dollars. Okay. Now 1 pound is $1.28. So 2,500 pounds, GPB, will be 2,500 times 128. So that's a multiplication. 128 is equivalent to 1 pound. So 2,500 pounds will be 2,500 times 128. That gives us 3,200 US dollars. So we can find how much she can spend. We know how much she's starting with, 3,200. We know how much she would like to take to Russia in dollars. That's 1,100. And we have 1,000 of the difference in the subtraction is 2,100. That's the amount she can spend in the US, $2,100. Okay, that's the end of the topics now for the quiz 8. There's a part 1 and a part 2. So you can actually look at both of them and use them to problem solve for your quiz number 8. And as always, if you have any questions after you look at this, then we will discuss them on a one-to-one basis. Just give me a call and we'll set up a convenient time to go over them. Thanks again for sharing, and I hope this made this clearer for you. And thanks again. See you on the next share.